Hello viewers, welcome to my YouTube channel. So in our previous class we talked about indices. We also discussed the rules of indices, but in today's class we're going to discuss exponential equation. Exponential equation. As the name implies, exponential equation involve exponents. So we know that the exponent of a base indicates the number of times the base is multiplied. But what happens if the power of a number is a variable, that is unknown? Now, when the power is a variable and if it is a part of an equation, then it is called an exponential equation. So we may need to use several methods to solve the exponential equation. Basically, there are three methods in which we can use to solve a problem on exponential equation. The first one we have is the logarithm method. The second one is the properties of exponential method. And the third one is the graphical method. But in today's class, we're going to discuss the properties of exponential function deeply. Now, at the end of today's class, you will be able to define and identify exponential equations. You will be able to solve problems on exponential equations, and also you'll be able to identify the real-life applications of exponential equation. So let's get started. So what is an exponential equation? An exponential equation is an equation with exponents, where the exponent or part of the exponent is a variable. So I've said it earlier that a variable is an unknown number. Basically, we can represent them with any letter, but the common letter we use include x and y. We can use any letter. Mathematically, an exponential equation can take the expression 2 raised to the power of x equals to 8, where your 2 is regarded as the base and the s, which is the variable, is the exponent or the index, exponent or the index, and the 8 is known as the basic numeral. The basic numeral. Now, this expression here is regarded as your exponential equation. Exponential equation. So there are several methods we can use to solve exponential equations. The first one is the logarithm method. The second one is the properties of exponent method, and the third one is the graphical method. So basically, there are three forms of exponential equation, or we can call it types of exponential equation. The first one is an exponential equation with the same base. That is, if we have 4 raised to the power of x to be equals to 4 raised to the power of 2. This is the first form of exponential equation in which the bases are the same. So in this case, we cancel out the base, and the x, the index, will be equals to what? 2, which is the index of the second base. Now, the second form of exponential equation is an exponential equation with different bases in which we can make the base to be the same. For instance, if we have 4 raised to the power of x equals 16, 4 raised to the power of x equals 16. Now, the bases are not the same, but we can make the base to be the same. In other words, we can say 4 raised to the power of x to be equals to 4 raised to the power of 2. Now, we've just made this equation to be having the same basis. Now we can cancel out, and our index will be equals to what? The second index, which is 2. Now, the third one is the case whereby the bases are not the same and we can't make either of the base to be the same. Now, for instance, if we have 4 raised to the power of x equals 15. Now, if you look at this expression, you will notice that we cannot make either of these bases to be the same. So in this case now, we have to what? Apply our logarithm method, and we take our natural log, in which our x will be equals to log 15 base 4. Log 15 base 4. In other words, if I take my natural log, recall that log 4 base 4 is always equals to 1. So if I take my natural log here, I have log 4 raised to the power of x base 4 equals to log 15 base 4. I can re-express this to be having x log 4 base 4 to be equals to log 15 base 4. Now recall that log 4 base 4 is equals to what? 1. Therefore, my x will be equals to log 15 base 4. And we can proceed by finding our final answer using what? Calculator. We should note that if your bases are the same, that is, you're having an expression of a raised to the power of x to be equals to a raised to the power of what? Of y. This implies that your x will be equals to what? To y. That's when their bases are the same. And in other words, when one of the base is not the same and you take a look at your equation, you can make either of the base to be the same to the second base. But in a case whereby none of the base can be made the same, all you need to do is to log both sides. You apply your logarithm method, your natural log. Now that is, if we have base b raised to the power of x to be equals to base a. Now this implies that your x will be equals to log a base b. Your x will be equals to log a base b. So this expression is the formula to calculate exponential equation with the same base and exponential equation with different bases. Now let's solve enough examples on exponential equation. Alright, the first question says evaluate 2 raised to the power of x equals 64. And if you take a look at this question now, the bases are not the same. So all we need to do is to make the base to be the same. Now we say 2 raised to the power of x. Now since the base here is 2, 2 raised to power what will give us 64. Now 2 raised to the power of 6 is going to give us 64. Now since the bases are the same, all we need to do is to cancel out the bases, the same base, and our x will be equals to what? To 6. That will be our answer for the first one. The second question, B, says evaluate 5 raised to the power of x plus 1 to be equals to 650 to be equals to 625. Now the base here is 5. Therefore, let's make this base here also to be 5. So 5 raised to the power of what will give us 625. So 5 raised to the power of 4 is going to give us 625. So 5 raised to the power of 4. We cancel out the same bases. So we are going to be having x plus 1 to be equals to 4. All we need to do here, this one has turned to a linear equation. All we need to do now is to collect the like term. Say we're going to be having x to be equals to 4 minus 1. Therefore, x will be equals to 3. The third question, C. Question C says evaluate 32 raised to the power of x to be equals to 0.25. 32 raised to the power of x to be equals to 0.25. We can change this decimal number. Recall from our previous class, I told you that whenever you encounter a decimal number when solving a question that involves indices, all you need to do is to change the decimal number to fraction for easy evaluation. So we're going to be having 25 over 100 because this is a 2 decimal place number. Okay, so the next thing we need to do here is to evaluate completely. So what do we need to do is to add square root to both sides. Now, let's make use of our power law. That is, we have 32 raised to the power of x raised to the power of 1 over 2. Now, this is equals to 25 raised to the power of 1 over 2 over 100 raised to the power of 1 over 2. Okay, so here we need to make use of our power law. For the power law, we are going to multiply the index inside the box with the index outside. So we're going to be having 32 x over 2 equals to, now, 25 raised to the power of 1 over 2, making use of our root power law. This is going to change to square root of 25 over square root of 100. Now, we have 32 raised to the power of x over 2 equals to 5 over 10. We can simplify this further. 5 in 5 is 1, 5 in 10 is 2. So we're going to be having 32 raised to the power of x over 2 equals to 1 over 2. Now, we can re-express this by saying 32 raised to the power of x over 2 equals to, my 1 over 2 can be re-expressed as 2 raised to the power of minus 1, which is also known as the negative index law. The negative index law. Now that the base here is 2, which is the smallest base here. So now let's also make the base for 32 to also be 2. So 2 raised to the power of what will give us 32. Now 2 raised to the power of 5 in brackets x over 2 close the bracket equals to 2 raised to the power of minus 1. Now that the bases are the same, so we are left with 5 times x over 2 equals to minus 1. So we're going to be having 5x over 2 equals to minus 1. Now let's cross multiply this. We're going to be having 5x to be equals to 2 times minus 1. Now 5x will be equals to minus 2. Divide both sides by 5. Divide both sides by 5. Therefore, x is equals to minus 2 over 5. That will be the value for x. Now, the fourth question says, evaluate 4 raised to the power of x equals to 1 over 1024. Now, in this case, we're going to make the bases to be the same so as to evaluate completely and find the value of the variable x. So 4 raised to the power of x will be equals to 1 over 4 raised to what power will give us 1024. Now 4 raised to the power of 5 is going to give us 1024. Okay, so we have 4 raised to the power of x to be equals to, we can re-express 1 over 4 raised to the power of 5. Recall our negative index law. So this can be expressed as 4 raised to the power of minus 5. Now we have made the bases to be the same, our x will be equals to minus 5. So minus 5 is going to be the value of the variable. So the fifth question says evaluate 1 over 32 raised to the power of x to be equals to 4 raised to the power of 2x minus 5. Now the bases are not the same, so all we need to do is to make the bases to be the same for easy evaluation. Now we have 4. 2 raised to the power of 2 will give me 4, and 2 happen to be the smallest base here, so we can put other index in brackets by saying 2x minus 5 close the bracket. Now 1 over 2 raised to what power will give me 32. 2 raised to the power of 5 will give me 32, so you can put the other index in brackets. Now recall our negative index law. The negative index law says that when you're having what the reciprocal of what of a base, you can re-express your base to be having a power of negative number. Now we have 2 raised to the power of minus 5x to be equals to 2 raised to the power, let's open the bracket, this will be 4x minus 10. Now the bases are the same, let's cancel out the base. We have minus 5x to be equals to 4x minus 10. Let's collect the like time. Collecting the like times, we're going to be having 10 to be equals to 4x plus 5x. So 10 will be equals to 9x. Divide both side by 9. Divide both side by 9. Therefore, my x will be equals to 10 over 9. Or you'll say 1 whole number 1 over 9 as your final answer. Alright, so I want you to try this question on the screen so as to test your knowledge on exponential equation. So if you find this content useful, please don't forget to subscribe to our YouTube channel. Click the notification button so as to receive every new video we're going to be dropping on this channel. See you in the next class. Thank you.